Welcome to episode 4, when we built an artificial intelligence on a PC. We provide a document, Accenture's TechVision 2021. The AI will analyze the document, apply BERT to the document, and we will encode a visualization in 3D of the sentences of the document clustered. And then I will deduct what is the content of the document that only the artificial intelligence has read. So here we start. We install our libraries, we install our dependencies, we load our sentences, we load our stop words, our sentence tokenizer, our word tokenizer, and then we load the already now pre-cleaned sentences that are in my file Accenture 21.txt. We convert it to a Panda data frame and we see we have 1,276 sentences. We do a little bit of beauty and then we choose a BERT embedding, a sentence embedding with BERT. John Snow Labs provided some pre-trained model for us, and this time we're going to choose a big one, a big model, a sentence embedding BERT large. It's about 1.2 gigabytes. You can download it for free from the internet, and we will apply it to our sentences to get a better result. At least we hope we get a better result. But before, if you are unfamiliar with BERT and you want to get a short overview, I put here some short explanation and a link to Archive. And also, since BERT is using a methodology called word piece tokenization, BERT uses about 30,000 word pieces. If you want to get an insight and short overview, I provided you with another literature from December 2020 regarding this topic. So here we go. We download BERT large. We define the shape, what is it? And then we just construct a new data frame where the heading of our column is called text. For the sentences, we have a look at the header, at the head of the Panda data frame and of the tail of the Panda data frame. And you can see that we have some sentences that are quite long. And remember, BERT has a token limit which you have to regard. Here we go, BERT large, and now we're going to train our model. We take our pipeline and we apply it on our text data frame for the column text, where we have all our sentences. And here we go. Last time with BERT base, it took us about 1 minute, and this time we're going to spend 2 minutes and 7 seconds on the computation. I have a Ryzen 5 3600 CPU with 6 cores and 12 threads. And since it's a PySpark 247 environment, all 12 threads run at about close to 100%. Now, if you have, for example, a Threadripper, or if you have an NVIDIA GPU where you can take advantage of its CUDA cores, you will be, of course, much faster than my local PC here. So what we end up is a data frame with each and every sentence has now an embedding. And this embedding, and this is kind of special, is now based on BERT large. BERT large has been trained for days on Google's TPUs, so there's no chance for you back home to get almost as close as Google did with its main infrastructure in the cloud. But we can use the result of this computation and apply it to our document. So here we have, it's a data frame sentence embedding where we have for each and every sentence an embedding based on BERT large. And of course, if you split it, you see that you have exactly 1024 coordinate sets that describe each and every sentence. You merge it together with the sentences and you end up with a shape of 1276 sentences, and each sentence has a coordinate set of 1025 coordinates. Of course, there's no real meaning to this coordinate set since you are not in an Euclidean space, or in a Hilbert space, a Minkowski space, or whatever. There's no metric at all defined. It's a pure topological space. Again, we can calculate the cosine similarity of a given sentence within the set of sentences. And you can see here, it takes milliseconds. I've chosen sentence number 15. Normal ways operating removed equation organizations prove good wheel technology, trying new things, unprecedented speed, innovate way forward, responsible and transparently. Heaven's sake. And the system was able to find sentences that are close to the meaning of these sentences, which in itself is unbelievable. And I'll let you have a look at it for yourself. Also, we can have a sentence, leaders, machine learning, university, and change. And I just delete university, leaders, machine learning, deep learning, we include change. We embed the sentence in our embeddings of BERT large, and then we calculate the cosine similarity for our sentence that it's not part of the original body of sentences. And my little artificial intelligence comes up with the following results. Come on. Come on. Yeah, that's a local machine designed for gaming. Sentence, leaders, machine learning, deep change. My artificial intelligence system says the next closest sentence with the same meaning is enterprise cloud adoption, accelerate phase, COVID sales research. Interesting. I think sentence number 2 makes more sense. Ecosystem scale thinking lead digital twin strategies. Enterprise engage wider ecosystem digital twins. Yeah, okay. You see the cleaning of the input sentences where we deleted all the fill words and the stop words and whatsoever. Improved the accuracy, but for the human readability, it suffers a little bit. Oh wow, this is all 2 sentences that are almost identical, except for business executives and executives. Okay, that sounds reasonable. But now to the most beautiful part. We have a data cloud in a high-dimensional topological space, and we want to induce a metric on this space. And the amazing thing is, with the advances in mathematics and applying algebraic topology to this system and construct, if you want, a topological space with a variable metric around each and every data point in the set, we are able to come up with kind of a distance function, which is absolutely fascinating. And if you have used PCA or TSNA in the past, this is really something specific. And I highly recommend it. Okay, having the new coordinate system where each and every sentence has here now 5-dimensional coordinate x, y, z, z1, z2. We can now cluster in the 5-dimensional space. The amount of clusters we get is 0 to 7. We have 8 thematic clusters. And again, all the sentences that the system says, I don't know if it belongs to cluster 0 to 7, I regard as noise. The system puts all those sentences in cluster -1. And here we have the quantitative analysis from 1,276 sentences, 443, that's quite a lot. The system says, I don't know what to do with this. I regard it as noise. It does not belong to the cluster structure I deducted for the other data point clouds in the topological space. I'll say, okay, I accept it. Then I do the calculation again for a 3-dimensional representation, because my eyes can only see in 3 dimensions and not in 5. But the cluster algorithms who applied the cluster methodology to a 5-dimensional space and hopeful a better, clearer cluster, we now take the same clustering and merge it with the 3-dimensional representation. And what we end up is, again, with a data frame where you have for each and every sentence, this is our topological or thematic cluster, cluster number 4, and these are the x, y, and z coordinates, and now in a 3-dimensional space. So BERT sentence embedding clustered in 3D. The result now with BERT large looks much nicer than with BERT base. Wow. Looking at the data topology in a topological space like we constructed here, you can see that's a much nicer structure with not at all huge outlines like we had in BERT base. But remember, every run can be different since we are applying a fuzzy logic algorithm here. So this will not be a result you can reproduce at every time you run this code. Okay, so these are the sentences of our document. This the AI identified as belonging thematically close together, applying BERT large. So let's have a look. If we find now a deeper meaning, without having read the document, if we can deduct what is the content of the whole document. Let's start with this cluster. Okay, let's read some sentences. Spacecraft mission control. Background noise suppression, remote working, remotely, layered environment. Pre-trained data models could use data, help diagnose, predict patient going ICU. Oh yeah, of course. Recognition, virtual simulation, synthetic data. Okay. Robots clear. New language generator, GPT. Oh, GPT-2 and 3, shockingly good and completely mindless. Hey, how can you write this in an AI document? Okay, we go on. Private beta version models developer got working discovering experimenting songs, line of codes, laptop checking security patches, AI factor, contact frame monitor patient, Guardian, NVIDIA, okay. PlayStation headsets, okay. Suppose these are kind of company examples applying technology and their results. Now for the deep blue cluster, base double again. Suppose an example of Zoom, a business example. Advertising spending globally began drop. Spotify saw threat. That's a business model. Globally, internet users were risen % last year. Consumer interest may correlate. COVID hotspot June. All-time high percentage reported. I'm not sure if I can make sense of the dark blue cluster. Accenture Research conducted global survey business executive capture insight adoption use emerging technology. Okay. They ask business executive for their insights if they use emerging technology. Okay. Global survey business executive understand perspectives adopting impact technology organizations. I hope so. Critical time risk everywhere company footprint spreading even wider. Review platform business customers leaned learned, I suppose, last year. Amazon Web Services. Okay, so from the content, I suppose these are business clients providing their experience, their expertise, and their insights when they applied different new emerging technologies. Let's go for the orange one. Here, Gartner analysis. Okay, technology foresight. Surprise energy wild chatter. Wow. Data powers digital twin entire factory. Here again, the topic of digital twin, healthcare. Clara Guardian. Okay. Clara Guardian hospitals. Okay. Masters change, moment of trio. Core systems build welcome. User base doubled. Anywhere information, please visit www. I can understand the sentence. Beautiful. Evaluate existing access, developing capabilities, longer put, focus, building technical wealth, microservices, revolution forefront, waste healthcare system. Now, I suppose the clustering of this set of sentences is based on the pre-training of the model that was not with the intention of a technology foresight or technology vision agenda, but rather on Mind innovation achievement gaps, true global access talents, risk-free playground innovation. Technology democratization, everyone. Innovator. Everyone is an innovator. I guess even in this cluster I have to perform a deep dive. Okay, let's see for the green cluster. Stack climate ambition shall use optimal self-assessment thinking data along digital transformations. Create engine continuous self-innovation, enterprise engage wider ecosystem, digital twins, make trust core design, principle new technology strategy, already business pursuing twin enabled visibility, select partners. Okay, again, this digital twins, this intelligent digital twins. Data cloud, Accenture cloud, first largest billion investment, accelerate client move, cloud, digital transformation, everything goes to the cloud. Honeywell, Forge, okay, another business partner combine digital efforts resulting in ecosystems generating novel solutions and new expectations. Whole industries, yes, yippee, cloud core company, periphery, technology. Longer one vehicle success vehicle possible success depends. Well, this is an interesting sentence. I would love to know the sentence without deleted fill words and stop words. Build new models of interaction, impact robotics, and move beyond walls. Enterprise, intelligent twins, powerful simulation capabilities. Oh yeah, this is the main topic of the document, I suppose. Data foundation place. Let's reimagine innovation process. Design new innovation processes with your simulation abilities, where you have a digital twin for each and everybody. Enable AI-driven generative design. Human worker systems iteratively work together, shrinking design manufacturing timelines significantly. Optimization everywhere. AI-driven generative design, human workers. I don't want to know the sentence in full term. Performing massive workflows. Reimagine physical space utilized. Robots alongside man innovation often present zero-sum option. That's an interesting interpretation opening up for us here. Twins, like simulations products, yet manufacturers may require yet another type of data. I guess I have to read this document. It sounds so fascinating. It must be gorgeous. I hope you already have read the document and you are smiling about my efforts here. Okay, the light blue cluster. Today, success coming, audacity, reimagine. Learn trends, years, technology, vision, think, apply, imagine, re-platform, business, leading change, needed organization, people, world. I can understand that the AI is saying, hey, finally I can make sense of those sentences, but as a human reader, oh, wow, man, oh man, eh? Great diversity, technology capabilities, available business today, creating limitless possibilities. Limitless possibilities, of course, if you hire your right consultant. Tapping today's wide range of technology options, who knows better? World Economic Forum recognized transformative capabilities along Accenture established set guidelines called Presidio Principle, Help Guide Experimentation, Powerful Technology. Heaven's sake! Okay, I think for the moment, those sentences, they have a complexity. They are a set of words. Heaven's sake. So, but luckily in our case, we have another code segment where we can find the top words of the sentences within the clusters. And again, Martin Grotendorst, he is a genius who wrote the following code. And I just apply the code a little bit. And here we come up with the answer of our personal AI system. Here is it. Again, we have the cluster, the amount of sentences within the cluster, and the top words or the top bigrams or top 3 grams within the sentences of these specific clusters. Digital twins, intelligent twins, digital. Okay? Real-time, historic data, machine learning makes completely sense to me. Supply chain, Ralph Lauren. Alright, technology, vision. Clara Guardian, I suppose this is a hospital. Work starts today. Absolutely. Think like technologist. Think like technologist. This is an interesting cluster provided by my little preliminary artificial intelligence system. Ignited new, technology capabilities available. Okay, I get where this cluster goes to. Leaders don't. Of course not. New normal, quick training program. Interesting. COVID, post-pandemic response COVID. Absolutely clear where cluster 6 sits. And if we have, over executed this. If we have a look at more than top 10 words, again, the same presentation, but with a little bit more words to understand the primary content of the cluster digital twins, intelligent twins, digital transformation, technology democratization, mirrored world, technological capabilities, process automation. I've read this already years ago. Real-time, historic data, machine learning, low-code, real-time data, twin simulation, intelligent twin, supply chain, technology vision, Accenture research, entire supply chain, Accenture labs, Accenture research, labs, Accenture. I have a feeling that there's a company hiding behind those sentences. Work starts today, executives report, future work starts today. I get an idea that there's some urgency to this cluster. Think like technologists, think like technologists. Remote employees working at home, enterprise need. The new future, the new directions, the need accepted. The employee's environment. Okay, remote work, clear. Ignited new, technology capabilities available. New area, business technology, technology strategies, technology capabilities. My goodness! A new world opens up here in cluster number 7. Cluster number 2, leaders don't. New normal, quick training programs, different organization. Training programs don't wait. Oh, that's the cluster of no, don't do it. New normal build, quick transfer, that's home. Interesting. And cluster number 6, our COVID cluster. Of course, the COVID response, the quick COVID response team, the pandemic organization. The structure of the organization and the pandemic would be interesting. Rapid digitalization, the pandemic world, the master change, the digital ecosystems evolve. My goodness, there's an interpretation unbelievable. This sounds really interesting, I guess. Now that I've done 2 readings of the AI result of this document, now I'm going to read the document for myself, and I'm going to be amazed what's in this document and how good my little artificial intelligence system running on my PC at home really is. And what are the next steps to optimize the algorithms and to even deduct more meaning for the content of our next document. Thank you.